finish off this discussion of utility validator, we move on to the last three methods. And it was a good point to pause, actually, because what we're going to do now is where we've always dealt with sort of strings in terms of our codes and so forth. We're now actually going to look at some ways in which we can use ints, which are numbers which we're going to need. So the first method we're going to have is, let's see, I'll move this up to the top and get a better set of zooming in, is called current letter score. Kind of think you know what that's going to do, don't you? So we go to our text file, we set a temporary value of 0, make a data table. You should be getting really used to that. We have a data table, then we loop through the data table. Then we look for our character that we've asked as a string letter to check. Okay, so we're saying we're making a character. Every time we go to a row, we make a new character. And if the character code equals the letter to check, we then return into temp score variable that we've got this value as an integer parsed. Now that depends on us making sure that this is always going to be valid. This should always be able to be returned as an integer by conversion through parsing. Really good to have a system, and we don't implement it here, where you could say that this is, does it have the right format? We don't go that far in this particular application, because it would add quite a lot of complication to the way in which we do things. So we're just going to say we accept that our text file is valid. We're not going to validate it for format before we start to use it. Bad practice maybe, but that's what we do. So we've got our current letter score. So that should be fairly easy to understand. Then we're going to get the whole string score. Now we've got an array of valid letters, and we're using the current letter score that we just created to go through each, there's the user string, through each element or character or item within the user string for, and there's a good use of a for, because we know the length in advance. We don't have to check while we've got anything or until or whatever. No, we've got it here. And we say temp score equals whatever it is now, plus equals this method, utility validator, current letter score, and so forth, to string. So that means that we've got sort of several layers of complexity within this particular line of code, and I fully referenced the module utility validator, even although I'm inside the same module, because I thought it would be good just to see that you have to sometimes fully qualify something so that you can use the features that it has. So then we just return our temp score. So then we've got the next one, which is the strength grade long, because I've got two ways of scoring the strength of a password or the strength of a signature. The full word, which is unacceptable, weak, medium, strong, or invalid. And then we're going to have single letter codes that make it easier for us to manipulate it when we come to use it in code. So we're going to have a string outcome, and we're checking a score that we've received. So we've added up all of the validated score of this particular password or string, and now we're going to check how strong it is. And we're using a nice switch statement. So we're checking this strength score against a range of values. Now what we've got here is actually quite a tricky technique in terms of it's slightly unusual, in that normally what we do is we normally just check whether a value is equal to something, but here what we're saying is, does it fall within a range? And we have to apply quite a tricky technique in order to get that to be able to be checked. And not only that, we have to make sure that we do our edge testing, our boundary testing, so that we would make sure that the plus or is greater than or equal to is valid, and so forth, and less than or equal to is valid. So this is a nice little technique. It's a nice little bit of code, and what it does is it shows you how to check a range using a switch statement. Really common, and in fact I believe that there are C# practice methods coming in which allow you to do ranges much easier in switch. I watched a video, didn't understand it fully, have to watch it again. So the final method in this particular class is called the character score for a single character, so as a single character. So for each, right, and we just return the character score that we get for that particular character that we're examining at the character code level. So we do exactly the same thing. We get our list of characters, we parse through it one by one for using the for each, and just return the score that we get. If it equals the character code, find the character score and return it. So that should be fairly straightforward and easy to understand. So you'll be pleased to know that that's us completed the code behind classes. We can now move on to the GUI. But I want to reiterate what I see as a fantastically useful policy when we're coming to creating applications. And I'm going to say, I know I said it a moment ago, but I'm going to say it again, is that by taking this approach that we have and provisioning ourselves with all of these classes here, we're now in a position just to use them. Because what we want to do is that when we're focusing on interface practices, we're just doing interface practices. We don't have to consider all this logic that we've had to create, and some of it's been reasonably complicated. And we're taking this chaining method, where one class will call another, and another will call another, and so forth. But they've only got one job each. I know that some of them will do lots of methods within that job, like our validator class that we just had. But it only got one job, it's to validate. And so that we do this chaining method, and so that if I ever want to add or manipulate the methods that are inside my validator class, I only change it in one place and I can call it whatever I like. And another thing that's true is that the way we're approaching it represents the way in which the things would happen if different people were doing different aspects of the application development. You remember I've said to you that there are GUI specialists making a lot of money as GUI specialists. There are people who do code behind, there are people who link to databases. And with a really good design specification, you've given the people that need the information, you the architect, everything they need to work that out. You've given them a signature to say, I want to do this, here's how it needs to do, and here's what needs to be returned by it. And when the other guy or the other girl who's doing the code that needs this gets it, it works. So we're splitting things out by responsibility as well as by style. It's really a useful professional approach, and it may be something that you could mention when you're discussing the application, saying that it was developed using a split responsibility basis. And it's really true. And it's a very, very realistic situation where different people might be doing different aspects. And you will remember that in RAD, that's really common, with a really tight definition where everything is known in advance. You can do RAD and just send them off to do the job and then glue it all together. And hopefully, it will all work immediately when it's joined together. But that's what we got. So what we move on to next is we move on to the GUI. And the GUI is interesting. It's really interesting, and I think probably what most of you will enjoy more than actually hard coding the logic. But the GUI won't work without the logic, and you've got to be really aware of the fact that without logic, your application is useless. So that's what we're going to do next. Nice fun stuff. We're going to create the interfaces, and it's a question of making sure that we do it step by step. We'll do interface, then code behind, and so forth, and we'll take that approach when we're creating our pages. So, something to look forward to.